Hello all. Today in this video, I'm going to scale the time histogram motions in another app called SeismoMatch. We know that selection and scaling of ground motions is very challenging, important, and initial step while doing linear or nonlinear time history analysis. In the previous video, we have already learned about the downloading procedures of required ground motions from PRNGA database as well as uh, demonstrated the scaling procedures in time in e-types. Okay, so today we'll do the same thing. We'll carry out the spectral matching or scaling the time histogram motions in another application called SeismoMatch. Here we see the screen of SeismoMatch. This is the student version. We have the option to use the trial version also, but we cannot do a lot of work in trial versions. For obtaining a license of student version, we have to email request email to SeismoMatch with our organization or institutional email so that we can get the academic license after certain time, 1 or 2 working days, so that we can input that license and obtain the academic version of SeismoMatch. Okay, so here basically there are three steps in the SeismoMatch to do the spectral matching or scaling of the time histogram motion. The first one is the input the source accelerogram, second one is the define the target spectrum, and finally third one is the spectral matching of the earthquake ground motions. Okay, so let me start with the input the source accelegrams. Here is the options to import the accelerogram. So let me click open single. I see some earthquakes which are already default in SeismoMatch application. So let me select one and let me see. It is a Landers earthquake of June 28, 1992. The first line is 6 and last line is 4815 with a time step of 0.01 second. It is a time and acceleration pair, and if we click OK, then we will see the time histogram motion of this reference accelerogram here. But before that, the first column is time column and the acceleration column is second column. Okay, and here is the different option. We see the different options to input the reference accelegrams. The first one is single accelegrams value per line. Similarly, time and acceleration values, multiple acceleration values, ESM and SMC format, PRNGA format, and shape format. So this format is time and acceleration value per line, and let me click OK. So we see the reference accelerogram here, the time series of reference accelegrams in terms of acceleration, velocity, and displacement, and the response spectrum. Okay, so here this is blank because we have not matched any spectrum. After uploading this, we have to go to step 2. But before that, let me again upload other time histogram motions as well. So let me click open single. Here I downloaded the time histogram motions from PRNGA database in the previous video. So I'm going to browse them. Let me click OK. Here we see the type of file, acceleration, displacement, and velocity file for 0 horizontal 0 and 90 degree, as well as off indicates the vertical earthquake. Similarly, easting, northing, and vertical earthquake for some other RSN number earthquake. This RSN is record sequence number 838 is that number. The earthquake name is Lander. So let me click one randomly. So let me click this one. So here if we choose a PRNGA format, we can see the data automatically transfer the required data here. Time step of 0.05. The first line is 5, last line 2404. The scaling factor once, and let me select OK. Yeah, OK. Yeah. If we select both, if we select both, we see they are overlapping with each other. But if we check like this, we see the earthquake. Okay, required earthquake. Yes. Okay, so for now let me select both and can refresh. And after this we can define the target spectrum. Okay, the target spectrum is the acceleration values, which is the acceleration value along the y-axis in terms of g and the time period. Okay, so define the target spectrum. Let me click this. We see the select input spectrum window. Here we have the option to define the target spectrum by different ways. So the first one is code based, which we see different code here, and I see somewhere there is NBC 105 1994 as well, but NBC 105 2020 is not uploaded in SeismoMatch. So if we click some random value and adjust the parameter, suppose UVC, we have the damping 5% seismic zone, we can input here. The soil type is here as for the UVC. And for example, let me go to IS. We see the different value. If we select zone 5, we see Z value of 0.36. Soil type C, risk category, business continuity category. It means the important class of the building. Okay, so I'm looking here the NBC National Building Code of Canada. Okay, NBC. Here we see the NVC response spectrum 1994, but I'll not use this one. And we can upload or define the response spectrum from loaded accelerogram, but it is not significant for today. So let me go to third step, which one is to load from spectrum file the damping value of 5%. Let me click OK. I'll go somewhere in my PC where I have saved the NBC 1052020 response spectra. Then I'll select type C, soil type C. So first line is 2, second line is last line is 62, period column 1 and acceleration column 2. Let me click OK. Then let me click again OK. So we see the target, we see the defined target or target spectrum here, or we define the target spectrum. Okay, so after defining this target spectrum, the another option and the final option is to carry out the spectral matching. Here we see the minimum time period of 0.05, which is very low, less. Let me keep 4 because this academic trial version, so you have the option only to 4 seconds to model the time or to show the time. Scale factor of 1 and tolerance limited 0.3. It means 30 per maximum 30% will be mismatch or misfit with this target spectrum. Okay, so let me click do matching. Here we see the accelerogram matching progress. Accelerogram matching the average misfit, maximum misfit, and the number of iteration to match the accelegrams will be shown here. Okay, so let me wait for a while, and after this matching has been finished, we will see the matched time to ground motion here. So this first one is the original acceleration time histories, and the second one will be the matched acceleration time histories. Okay, so we see if we see the time series response spectra and mean spectra, yeah, we see the matched accelegrams time series. Okay, so yeah, this one is the matched accelerogram time histories. So after matching we will get the response a time history like this. So if we go to time series, we see the original time series data and the matched time series data. We can select, double click somewhere and select all and copy with the right selection and copy to Microsoft Excel or in the form of notepad or anywhere further to input for analysis. Okay, so if we see the response spectra, yeah, the first original accelerogram means the yellow one is indicating the original accelegrams are response spectrum of this Lander earthquake, and red one is the target spectrum. And if we see the matched accelegrams, we see the matched target spectrum, sorry, matched response spectrum. Here we see some unfit. So we have seen that average misfit and the maximum misfit, which is in the range of 22%. And we see the comparison here. The original accelegram is too high as compared to the target uh, uh, response spectrum, so that it is scaled down from peak 2.7, I think this one, to 0.87. So while doing the scaling, we should be very careful about the frequency content. Okay, the too much frequency alternation or change in frequency would be responsible for change in the damage pattern of the structure while doing nonlinear or linear analysis, so that we will not get the desired result after the analysis. So while selecting the earthquake ground motions and while scaling also, we should be aware, so that the result will be stable and the result will be expected as expected. Okay, so this is just for demonstration purpose, and the scaling factor should be in the range of, I think, 0.5 to 2 or 3, in which many researchers or scientists have identified the range of scale factor. So we should be stick on that in order to have the better result. So we see if we see the ground motion parameter before and after the scaling, we see the maximum acceleration of 0.78 and it is reduced to 0.4293 after the matching. Similarly, velocity is also changing, and we see the displacement is also changing, acceleration and frequency content. I think this Bmax by A max, velocity max by amplitude max, this parameter content frequency uh, parameters, so frequency content, so this is also changing, and most of the parameters are changing while scaling the earthquake, so we should be aware of that uh, changes. Okay, so here if we see the table of this spectrum, matched response spectrum, we'll get the table and we'll copy into another format for further analysis. So if we go to file and I think go to save project, yeah, it will be saved somewhere if we click the save project. And if we have to export the spectrum or response spectra or time history record with another option, we can click go from the file export option. So here if I click export record time histories, I see the save acceleration time histories window. Save data from the original acceleration and the match acceleration. We have to choose either we need both or we need the scaling one. For now, I can go for save data from the match accelegrams. So specific accelegrams indicates the accelegrams from the earthquake which we have done the matching procedure. All accelegrams are specific, it depends upon the choice. So here export time and acceleration. So I think for now I'll export only time and acceleration, and this is the folder where we have to copy or where we have to move export this acceleration time history. So let me click Suppose somewhere go to user C user. Let me search desktop. Okay, so let me create file. Yeah, here I see the text file in the form of notepad. Oh, so before going to export, we have to save the project. Okay, without saving, the data cannot be exported. So I save this project in desktop somewhere. You can save this, and after saving the project, we can start exporting data. Okay, so let me keep the same and the text file in desktop. So let me create file. I think here this is the saved file, and here the match accelerogram data. Okay, so here we see the data in the form of time in accelerogram. So if we select this, copy, and go to Microsoft Excel, paste. Okay, then let me select this one. If I go to plot this data, I'll get the matched or scaled time histogram motions, okay, which we have to apply during the analysis. So by this way, the scaling procedure can be completed, can be done in SeismoMatch, and export the data in the form of text file. Okay, if we have to export the record spectra, mini spectrum, similar procedures we can follow and save the file. Okay, so by this way, the reference ground motion times to ground motion can be imported, defining the target response spectrum, and finally carry out the spectral matching, and then export the data in the form of text file or in the form of CSV file can be done with the help of SeismoMatch. Okay, so this much for today. Till then, don't forget to like, share, comment, and subscribe my YouTube channel. I will be presenting. I will be coming with another informative video after a while. Okay, thank you so much. Bye bye.